All right, good morning. Welcome to the session on Get Reactive with RxJS. My name is Venkat Subramaniam. I'm going to talk about just a little bit about reactive programming in the beginning, and then I'll talk a little bit about what our RxJS does and how we can make use of some of the things it provides. Best time to ask questions or make comments is when you have it, so please don't hesitate. Anytime is a great time. So let's get started. Well, reactive programming has been gaining quite a bit of interest and popularity in the recent times. So we begin to wonder, why yet another new programming model? Well, one of the things I've learned over the past few decades is we work in a field where we give a new name for what we already do and get really excited about it one more time. Well, this time the things that we're getting excited about are things like microservices, reactive programming, and things like that. But it turns out they're not entirely actually new at all. In fact, reactive programming is something that the concepts have been around for quite a long time. So in a way, if you really think about it, it's more of a re-emphasis of things we have already done. We can probably relate this to what extreme programming did, for example. Well, what did XP do? XP had really nothing new, and except that probably the only thing new in XP was a re-emphasis on 12 different practices. In a similar way, reactive programming emphasizes certain technical things that we should think about programming and emphasizing in how we develop applications. So the question really is it really new? And the answer is no, except for the re-emphasis. But what is it really? Well, if you really think about it, things have changed quite a bit in the past, maybe 10 years, give or take. I almost am tearful when I think of those nostalgic days when I used to wake up in the morning, and as my coffee pot is brewing coffee, I would turn on the modem, and it would dial and redial, and I can hear the whoosh noise in my ears. Well, those days are long gone. Now we carry on ourselves multiple devices that are internet-enabled. It's unbelievable how much we are communicating with applications today. And in fact, that's one thing I would say has completely changed in the last maybe 10 to 15 years. It used to be that companies made applications for their employees, and the employees using the applications would then interact with the customers. Well, when employees are predominantly using applications, those are called captive users. When users are captive, they don't have control over what the applications do. They pretty much have to use what's given to them. Well, clearly what's happened in the past about 10 years is companies have started providing applications for end users rather than their employees to use. Well, end users, of course, are not going to be that kind and captive as employees do. And even if it doesn't matter what the size of a company is, we can argue that you're probably going to have a lot more customers than employees, so which means there's an explosion in terms of how many people end up using applications. The other thing that's happening is the type of applications and the interactions these applications are having with the data and with the applications themselves. The biggest geek that I personally know, I would say, is my son. The other day I patted him and several devices fell off him. I don't even know how many he is carrying around. Well, we're talking about people using multiple devices. Every one of us is carrying multiple devices. People are talking about internet-enabled devices, but forget about, watches, if you will. We are talking about earrings and nose rings and tongue rings, all internet-enabled and constantly communicating with applications. Well, that really means that we need a greater demand. We have a greater demand on applications and how these applications interact. So how do we go about managing and building these applications? Well, we can apply some of the learnings from the last few years to maybe a decade. And one of them so reactive programming really brings together 4 different practices into a single mold. And the very first thing it says is we should really consider using elastic services to scale. Well, that's kind of what we have done over the past several years is we have gone into cloud computing. It doesn't really make sense for majority of the organizations moving forward to manage their own IT infrastructure in terms of systems, if you will. It just is unbelievably not only expensive, but really hard to manage these systems. Well, today we have learned that we could easily spin off servers on the cloud very easily without much effort at all. And of course, these servers can be brought down very quickly. More servers can be brought up based on the demand. The demand could be based on the time. The demand could be based on the load, actually. And so one of the things that reactive programming says is we should really make use of elastic services as much as we want to really provide scale. Well, the second thing it really emphasizes is that we should really focus on message-driven systems. Well, I'm going to say that having a distributed database or even having a centralized database and having distributed transactions is so 20th century. It really makes no sense to be moving in that direction. We should really think about disparate systems communicating with each other using messages. That's another thing that it's heavily emphasizing, is more of a message-driven systems for communication. Well, then of course we want responsiveness. Why is responsiveness so important? Well, in the day we live in, we are really living in a world of instant gratification. The days of where you use an application and you patiently wait for it to respond is gone. Well, people go to applications. If the applications don't respond for a few seconds, they just simply leave. They go on to use other applications. Responsiveness is probably one of the most important things. For example, let's say it's a kind of a quiet Sunday morning. You decide to walk into a store, and as soon as you walk in, you realize that the clerk is busy helping another customer. So what do? You probably wait for a few minutes, you look on the shelf, look on the floor, look on the ceiling, and then you quietly leave. Why? Because there was no response. On the other hand, let's say you walk into the store, and as soon as you do, the clerk who is busy takes a pause, looks at you, makes an eye contact, and says, "I'll be with you shortly," and goes back to work with the client they have. What do you probably did? Because of that, you probably waited for several more minutes. And why is that? Because you felt you are important, even though you know you're not. So the point really is that when there is responsiveness, you normally hang around. When a system is not responsive, you pretty much leave. Well, this is what we have learned, for example, with infinite scroll. Remember the day that you got exposed to infinite scroll. This application that's been around, sluggish and a little slow, responded like a snap. You're like, wow, that was really fast. What happened? And you scroll down, only to realize there's nothing in the bottom, and then before you could immediately realize it, something filled up in the bottom. Wow, that's pretty nice how responsive this application is. So responsiveness is extremely critical, and reactive programming says the goal is not to give all the results to the customers or the users. The goal is to give them enough for them to process while they're doing it, go back and pull more information and be responsive. Well, the fourth aspect that reactive programming greatly emphasizes is that applications have to be really resilient. Now, why is resilience so important? Well, if application is not responsive, application is really also very poor in terms of how it fails in an ungraceful manner, you're not going to really be hanging around with applications. So resilience of applications is extremely important. In other words, it says that we should treat failure as first-class citizen and program for these failures as well in a very graceful manner. Well, that's pretty much what reactive programming is emphasizing, is all these four things. But what does it really mean to develop applications in a reactive model? I want you to step back and think about what we've been doing for, maybe about 20 years now. And we could argue most of what we've been doing, pretty squarely falls into CRUD applications. And at some point, you begin to ask the question, does everything simply become CRUD application after all? And it turns out maybe we've gone a little overboard with it. Maybe not everything is CRUD applications where we create data, read data, update data. What if we can think of applications where maybe we are the middle agents? All we care about is some data that's flowing through, and we want to process some data and then send the data along the way. We're not in the business of accessing data from a database in the traditional way. Maybe we're the intermediary just interested in processing data as it flows through. As it turns out, there's a lot of applications that fit into that kind of model. For example, let's say you are interested in processing stock data. Well, you're not really interested in reading the data from a database. Maybe there's this flow of tickers and prices, and you want to really make decisions along the way. Maybe there is a particular ticker you are interested in, maybe a price range you are interested in, and maybe you want to take an action if it falls in the range of price you are interested in. Otherwise, simply let it go through. Well, that could be a way to think about how we are being reactive to data that comes towards you or flows towards you. So I want you to think about a little bit about data flow computing rather than thinking about CRUD operations. Well, the concept of data flow has been around for a very long time. This is not new at all. You couldn't possibly have gone through the 80s without hearing about data flow computing, for example. Well, the beauty of data flow computing is when data is available for something to execute, it's ready to execute your computation. So true parallelism actually exists in data flow computing. So you can actually do quite a bit of computing in data flow. That's one of the concurrent computing in data flow. That's one of the exciting things about it. There's a lot of other things that fit into this. For example, what if you're interested in monitoring tweets or other messages, and you want to respond to some of the messages if they are relevant to maybe your business or line of work or whatever keywords that you're looking for? Or what if I'm interested in processing weather data? Well, I could be in a situation where the weather changes very drastically, and I want to respond to it very quickly. There are applications that are being developed where you're responding to weather changes, and you want to be able to respond through it in a very high throughput. Well, this brings up this idea of streams of data. So in other words, rather than looking at data as this piece of information you fetch and then do some work and then update, what if data becomes a stream that flows towards you, and you want to be able to process the stream of data and take actions and maybe pass it along as in the stream for the downstream entities and computations to take note of it and do processing? That's basically what we are looking at in terms of how we're going to compute it. So this brings up the details about a programming model. Well, at the very essence of reactive programming is this idea of observable. Well, once again, you may notice that observable is nothing new at all. It's been around for a very long time. Well, then how is reactive programming's observable different from the observable model that we are, so very familiar and used to? There is probably maybe three clear distinctions between the traditional observable and what the reactive programming observable model provides for us. Well, the very first thing about the traditional observable is you have an observable, which is the source of the data, and you have, of course, the observables, which are the receivers of the data. And, of course, the source could be sending the data, the receivers could be receiving the data. Well, the observable model in reactive programming clearly sets apart two different channels. Think about this as a data channel and an error channel. The data channel would, of course, have the data, and the error channel would contain, of course, the error. Well, this is one thing we have suffered with for a very long time. How do we really separate and deal with data compared to error or exceptions in the programming models? Well, way back in time, what we did is we returned data or the result when you called a function. Well, if something went wrong, how do you tell that something went wrong? Well, we said we could return a negative result to say that something is wrong. And then we quickly realized maybe that's not a good idea, because some data could be negative numbers as well, and some data may not be, after all, numbers. It could be something else. Gosh, how do we deal with it? And then we said, well, here's a brilliant idea. We'll return an error as a response to functions. So if there's nothing wrong, we'll give you a 0. And if something is wrong, maybe we'll give you a number to say there's an error. And what about the data itself? Well, we'll pass in an object to the function, which can populate the object with the result and send it back to us. Very quickly, that became really unwieldy to deal with. And then we said, well, here's a great idea. We'll return a result when you call functions, but if something went wrong, we'll throw an exception at you. That was a terrible idea in itself, because exceptions started disrupting the call stack. And then, of course, that became a little bit more expensive, hard to really handle also. And then, of course, it requires a lot more extra programming effort. So we've been struggling with errors and how to deal with for a very long time. Well, reactive programming says, what if we have clearly two different channels of communication? One channel is the data coming through, and the other channel is for errors. So clearly you know what you're receiving, an error or a data that comes through. The second problem is this idea of exception handling is a terrible idea from the point of view of functional programming, for example. Well, it turns out reactive programming is a nice logical step from functional programming. Well, in functional programming, we talk about using a function pipeline, and then we talk about lazy evaluation. Well, reactive programming kind of starts right there and says, what if we take this pipeline of data coming towards us and we want to process it? Well, in an imperative style of programming, you make function calls. If something goes wrong, you blow up the call stack and you retract. Well, that doesn't quite make sense in the concept of reactive functional programming because you don't disrupt the call stack that way. You're downstream and you want to keep flowing down. And what do you do when there's an error? Well, you don't go back. You continue to deal with the error like it's a data. And that's exactly what reactive programming says. Let's deal with data and let's deal with errors like it's data as well, and just keep pushing it downstream and handle it. Well, that's a very first clear distinction. You got a data channel and you have an error channel. Well, the second distinction is when you have data coming through a data channel, the minute something goes wrong, you would get an error through the error channel, and immediately the data channel would terminate. There will be no more data coming through the data channel. So in other words, it's kind of like a circuit breaker already built into the observable. If everything is going well, you get a stream of data coming through. If something were to go wrong, an error gets emitted, and there's no more data coming through the data channel. And lastly, you also have a third channel, which is called the completed channel. This is a clear way for you to tell your receivers you don't have any more data, and you're not going to send anything more, so they can do their cleanup operations and know that they have reached an endpoint in the data. Let's take a look at these examples with RxJS. So the concept of reactive programming has been around for a while. It was actually introduced by Eric Meyer as part of a solution in Rx.net. Well, it's been around in Rx.net for quite a while in the .NET community. Well, generally one of the things I've observed is I work on, multiple technologies. I got my hands in C# and related technologies. I've got my hands in Java and JavaScript as well. But I kind of look at these different platforms, and I've noticed one thing very clearly different across these. The .NET community is kind of special in that they'll quietly sit down and take solutions given, and they would get their work done. The Java and JavaScript communities are very different. The minute you show them a solution, they wouldn't sit there and use it. They would turn around and develop 20,000 frameworks around it and celebrate the frameworks they develop. Well, that's exactly what happened. The quiet Rx implementations was around for a while until the Java folks and the JavaScript folks discovered this, and they went on to create hundreds of frameworks and libraries around it. If you look at Java itself, there are so many solutions available for providing reactive solutions in Java. Likewise, there are a few in JavaScript as well. One of them is RxJS. I'm seeing RxJS gaining popularity. A lot of other tools and libraries and frameworks are beginning to use RxJS also. For example, just one example is, if you're using, for example, Angular 2, well, in Angular 2, when you make a request to the server, the HTTP module internally uses RxJS to pull the data using the AJAX calls. That's not a requirement that you have to use it, but that's a default implementation you get in Angular, for example. So you begin to see this in quite a few places. So you will run into reactive solutions in one of two different ways very quickly. One is you decide to create a reactive applications all by yourself, in which case you're getting dragged into reactive programming quite easily. Alternately, you may not care about using reactive solutions directly, but the libraries and the tools and the frameworks you are using for building your applications internally begin to use reactive solutions, and you would get dragged into it fairly quickly as well. So let's take a look at an example of how we would create an observable in RxJS and how we would use it. So what I have here with me is a little page which is called the index.js. Don't have a whole lot here, but I'm referring to the RxJS. That's pretty much the first thing you see here is I've brought in a reference to RxJS from the CD, and that's all I have. Well, of course, I have a little page here. I'm going to simply say hi, and I hit the save, and I'm going to simply refresh that here and display it. As you would see, is that display is going to simply show the hi. So I'm going to make some changes to the application, see its response over there. I'm going to build a few little examples and play with it. Well, what am I going to do here? Well, I want to clearly see an example of building a little reactiveness here. So I'm going to start with a little function called the isPrime function. Well, simply put, isPrime simply tells you whether a given number is a prime number or not, using a fairly simple solution. It just iterates through the number, sees if it's divisible by any number other than itself and 1, and then if it is, it says that it's if it's not a prime number, otherwise it returns a true to say it's prime. but I want to really start generating prime numbers as a sequence. So what am I going to do to create it? Well, I'm going to say primes equals, and I'm going to go to Rx, and I'm going to create an observable, but I'm going to call a create function right there to create the observable. Well, it follows the model of rather than using a constructor, to use a static method to really create the object. So in this case, the create function is going to really create an observable and give us the handle to this particular object. Well, of course, I want to use this observable in just a few minutes, but what am I going to do here within this observable? Well, I'm going to receive a subscriber as a parameter to this particular observable. So in other words, the create method receives a callback, and this callback says, when you call me, well, you are going to provide me a subscriber, and I'm going to start emitting data to the subscriber. That's the key word to think about, is the emit. So you're going to emit data, as in when you are really interested in emitting data, you're going to emit data. So what am I going to do here to make that work? Well, first of all, I need a function right here to work with. So I'm going to create that little function to work with. So what I'm going to do in this function is I'm going to say count is equal to 0, or let's go ahead and say index is equal to 0. And let's start with a 1, actually. And then I'm going to say over here, while index is less than, let's say, about 10,000, well, what am I going to do here? Well, in this case, what I'll do is I'll first of all say if index is a prime, so is prime of index. Well, if it's a prime number, then I will emit the data. So I'll go to subscriber and say next, and then I will say send the index over. And then, of course, I will go ahead and increment the index right after that, and then I'll continue the loop after that. Well, so what are we doing here? Well, notice the call to the next method. So the next actually is a way for you to push data through the data stream that I talked about. So this is where you get the subscriber, and as an observable, you can start emitting data by calling this next method, and that opens up the data channel, and you send the data through this data channel. How do I receive this data on the other side, the receiving side? Well, here's an example of that. So I'm going to define a function called subscribe. And this function subscribe, what this is going to do is simply say, go to the primes, and I'm going to say subscribe to that particular primes observable and send a subscribe call. Well, the minute I subscribe, it's going to send me data through the data channel. Well, how do I get the data through the data channel? Well, that's my very first argument that I provide to the subscribe function is yet another function. So I'm going to say prime over here, and as soon as I receive a prime, all I'm going to do is simply display the prime here on the console so we can actually see the prime that we are receiving from this function repeatedly. So let's just go ahead and try this out here on the console. So I'm going to call the subscribe method, as you can see right here, and have it really execute things for us. Well, it's helpful to save this function, obviously. Go ahead, please. This one here, line 15. Okay, so this is going to be indexing. Thank you for the catch. Absolutely. So we are incrementing that, and we are. So I make mistakes, some intentional, some not. But that helped me to know if anybody is still awake here. So that's good. So that's a good feedback. So right there is the index plus plus. And of course, that's going to keep incrementing and sending it. If it's an index, it's going to emit it. Otherwise, just increment the index and keep going. All right, let's go ahead and try this out. So what am I going to do? Call the subscribe method. And of course, I'm going to say subscribe. Oh, it's not defined, it says. Of course, it helps to save this function. So I'm going to go ahead and save that. And of course, call the subscribe function. It still says it's not defined. So let's subscribe. So let me make sure that I defined it properly. That's a subscribe method. And of course, it would be helpful to invoke this function as well. So let's go ahead and bring it. So script, and I'm going to say source is equal to the function.js that I want to bring in. So let's go ahead and make sure that's tied in to this particular function. All right, so now I'm going to go ahead and call this particular function and have it really evaluate it. And then, of course, we'll see what it does. Well, there's a little bit of a syntax error that I need to work with. So let's see what the problem here is. So it's complaining that get is, well, it's having a function with the function.js. So it's complaining it couldn't find the function.js. Let's see why that's complaining. functions. Oh, did I call it functions? You are right. Good eyes. There we go. Awesome. So now that I've got that squired out, let's go ahead and call the subscribe method. And right there, you can see that it emitted a little silly little example, but nevertheless shows us the point how this actually works together. So what did we just do in this case? We called upon this to give us all the prime values, assuming I implemented it correctly, but don't worry about it. The factor is that it's actually pulling in the data and displaying the values. So when I called the prime, I went to the observable, and I said, hey, observable, start emitting data. I want to subscribe to you, and start emitting data. When you get a data, send it to me, and I'll decide what to do about it. Well, the observable itself said, hey, subscriber, thanks for subscribing. I'm going to start emitting prime numbers towards you, and it's sending it. Of course, this could be across systems if you have to, and you can communicate through this particular observable as and when, where it may make sense. So that gives you an idea about how to really subscribe and start receiving data. But I mentioned that there are a couple of different channels to work with. Well, one of them is the so-called completed channel. So let's take a look at what completed really means. Well, notice in this case, when I'm done with the data, I want to tell the receiver, I don't have any more data coming towards you. So you can say subscriber.complete, and you can send a clear signal saying that I'm done, I'm not going to give you any more data. Well, just to prove the point here, because I emitted a complete signal, the way the observable is built already is there'll be data being emitted through the data channel, but the minute something comes out of your error channel or the completed channel, the data channel will close up, and there will be no more data coming through the data channel. Not that you want to keep emitting data after the fact, but just to prove the fact, if I say subscribe, and I'm going to send a -1 here just to prove the point. Now, clearly, in this case, I'll comment out the complete, and you can see that I don't have the complete right now. But if I call the subscribe, in the very end of this, you will notice that it is going to come in and display that particular data. Well, did I go through a loop, actually, in this case? Sorry, this should be not subscribe, but subscribe.next, isn't it? There we go. I'm slipping at the wheel here. So subscriber.next, not subscribe.next. There we go. So I'm going to send that next command here to say that I don't have any more data to send you. Basically, this is going to be the completed request to say that I am done with this. Let's actually restart this to bring this back in. So pardon me here. That's kind of stuck in there. So let's go ahead and kill that. Let's actually forcefully kill it. There we go. So in this case, of course, I'm going to, let's restart it. There we go. So, all right. So I want to restart this little thing and ask it to run through the subscribe. Let's just fire this up again. So what am I going to do here? Well, clearly, in this case, I want to call the subscribe method. So there we go. And what does subscribe do? Well, in the very end of emitting all this data, we're sending the subscriber next is -1 to signal that I have a little, next to pass the data on the subscriber. So, so in this case, let me get this correct. There we go. So what I can do, though, is I can send a completed. So let's go ahead and say subscriber.complete. What does that do? Well, it's going to send a completed signal. And as a result, we're not going to get the last -1 being sent because the data channel has been closed, like I said. But of course, on your side, what you could do is you can also receive that to handle that. So let me just put an error right here. We'll come back to the error in just a few minutes. But I'm going to say in here, well, how about simply saying done over here to signal that I don't have any more data coming through. So if I were to go back and call the subscribe now, you can see done being displayed right here. Well, that's because when the observable emits a complete signal, you get that signal through your complete channel, and the data channel shuts up at that point. Well, so we are seeing the 3 channels here right in front of us on the receiving end. The first line 25 is the data channel. The second line 26 is the error channel. And the last line, of course, is the complete channel. And like I mentioned, the data channel will only receive data as long as nothing has come out of the error channel or the complete channel. That's already baked into observable. That also shows you how observable in reactive programming is different from the traditional observable that we are used to. Well, but on the other hand, there's also times when, as a receiver, you want to communicate that you don't care about some data anymore. For example, let's say you go to a particular resource and you are asking it to emit data, let's say a stock price. You are interested, let's say, in buying Google stock, but you want the price to be over 700 before you buy it. So you put a little request to say, keep telling me what the price of Google stock is. Well, then you suddenly see the price just hit a little bit above 700, and you really, really want to buy this right now. Well, now you're saying, wait, I'm going to go do the trading, but I don't want this silly service to be sending the data anymore. I am done with it. I'm going to switch over to doing some other work. So in other words, you want to unsubscribe from as a subscriber. You want to say, don't keep emitting any more data. I don't need this anymore. So there's got to be a way to communicate your intent. And why is that? Because that can result in better use of resources, both on your side and on the service side as well. So it gives you this two-way communication to go back and forth. So what am I going to do here? Well, what I'll do here in this case is I'm going to rewrite this little example to provide that behavior. So first thing I'll do here is I'll create a subscriber right here on this side. And this subscriber, I'm going to say this subscriber is going to be saying, I'm a little function. Well, if you're programming in C# or you're programming in Java, typically you implement interfaces. Well, JavaScript doesn't have the concept of interfaces. JavaScript is dynamically typed. It's extremely flexible. So you pretty much can create a JSON object which has a certain objects and properties in it, and you are good to go with it. So in this case, I create a JSON object with a function called next in it. And this function says, I'm going to receive a prime, and all I'm going to do is simply print the prime. But in addition to doing so, what I'm going to do here is, I'm going to say, well, if the prime number that I received is greater than 5,000, I'm going to say subscriber.unsubscribe, and I can then say, I don't want this data anymore, and I can switch off getting the data from this point onwards. Well, clearly in this case, let's comment that out again for a few minutes. We'll come back to that. So now that I've created a subscriber, I can say prime.subscribe, and I'm going to send the subscriber to that as a parameter, an argument, and say, here's the subscriber I want to use. So rather than providing the function in place, I just gave it a JSON object which has the next method. Clearly, you could also provide a JSON object with the next complete and error for the 3 channels we talked about. Well, let's go ahead and try this out, call the subscribe. And in this case, of course, I'm going to call the subscribe method. Let's make sure that I call this correctly. So the subscribe method is going to subscribe with the prime and say, I'm going to subscribe with it and pass the subscriber to it. Well, but what in the world is this prime? Prime is not a function, it's complaining. Does anybody see the error that I did here? It's primes, not prime. There we go, that's why. So let's go ahead and call this again. So in this case, of course, I'm going to call the subscribe method. And it went through and gave you all the numbers until it reached 10,000. But notice in this case, the minute I reach 5,000, I want to tell it I don't want the data anymore, and I want to unsubscribe from it. So I can certainly do that as well and say, don't send me data once it reaches 5,000. I want to unsubscribe from it. Well, in this case, of course, you can see it went to 5,003, and it's no longer going to send me data anymore because we did unsubscribe. That gives a way for your subscribers to dictate what's being sent versus what's not being sent. Well, that brings up the next question. You got observables, and you got the observer, and the observer is going to keep emitting data. The observables can see the data, but what about having multiple observers? Well, sure, you can have multiple observers to the same data source. Well, if you have multiple observers to the same data source, what's the behavior of the observable versus the multiple subscribers or observables? How does that really work? Well, let's think of a couple of different examples. You have a data source that's emitting data, and you have subscribers subscribing to it, but what do these subscribers actually see? Well, if you're watching a public event, for example, well, the public event is going to be what you are seeing, and if somebody comes along, they're going to see at the particular time, the event that is actually happening. So for example, if somebody opens the door and walks into this room, they're going to see the talk in the middle of what it's happening. I'm not going to stop what I'm talking about because one person walked in and say, folks, sorry, I got to start over from the beginning. That's not going to happen. Well, in other words, in this case, of course, you are watching what everybody else is watching, and all the subscribers are watching the same exact roll of events that is happening. That is called an hot observable. On the other hand, if you're watching a recording of this talk, and if somebody calls you and says, what are you doing? Well, I'm seeing this talk on YouTube. Well, if they go to YouTube, chances are they're going to start from the beginning of the talk and watch. You could be in the 15th minute of the talk, but they would be starting at the first minute. And of course, by the time you are done, they would be still in the middle of the talk they are watching unless they quit in the middle. Well, that's called a cold observable. So a cold observable is going to be having multiple different sessions for its subscribers. Hot observable manages those sessions together. Let's take a look at an example to see how this actually works in here. Well, for that purpose, what I'm going to do here is I'm going to create a slightly different index file to work with. So let's take a look at this, a little change I made in this index file. So what I've done in this index file right now is I've created two buttons, subscriber 1 and a subscriber 2. And of course, I only have one method called subscribe that I'm going to call. But the subscribe method is registering two different elements on the HTML page where I'm going to display the stuff. Let's just get this rolling, and then we'll come back and talk more about it. So I need a function called the subscribe. So let's keep everything up here until now, but I'm going to create a subscribe function. Well, this function takes a display, as you would see, but what is this display going to do? Well, I'm going to say primes.subscribe, which I don't have yet, but we'll come back to it. And if you give me a prime, I'm going to simply say display.innerHTML equals, and I'm going to simply display the prime onto it. So if you give me a prime number, I'm going to display it on that particular display and show it. That's all I'm going to do. But that begs the question, what is primes? Well, primes is equal to RxObservable, like we did before, but .create. Well, in this case, of course, I'm going to take a subscriber, and what I'll do here is I'll say let next prime is equal to a function, and I will also start, in this case, with an index value in the beginning. So let's say let index is equal to 1, but then what I'll do here is call the next prime right off the bat. What am I going to do within the next prime function? I'm going to say if is prime of index. Well, if it were a prime number, then I would say, well, subscriber.next, I'm going to emit that particular index value just like we did before. But then what I'm going to do is I'm going to take a little break and then repeat this. So index plus plus, and then I'll say set timeout. And in this case, I'll call the next prime, but after a slight delay of 100 milliseconds. So in other words, what I'm doing here is when you come in, I'm going to first of all call this next prime function. The next prime function checks if a given index is prime. If so, it emits it. And then it increases the index, and this time I remember to put it outside the if. And then, of course, in this case, it takes a break and repeats after a little timeout. Well, that's a good start. Let's see how this is going to work. So I go back here to the subscribe and call this method to subscribe. And of course, you can see that it's counting the primes and displaying it along the way. But the question is, what's going to happen if I click on the subscribe on the second one right now? Well, before we click on it, let's quickly take a look at what the code is actually doing. When you call subscribe the right one, it's going to call with the display 2 as the element to display into. And what is this guy going to do? Well, this says I'm going to call subscribe on the observable. Well, clearly, that's only one observable in this code because primes is the object we created on line number 9. So that's one single observable. But we already have a subscriber. Now we have a new subscriber coming in after all these time units in this case. So what's going to happen? Well, I click on the subscribe, and you can see that it started from the beginning. Well, why so? The reason is there is a session being maintained by this particular observable, and the session is right here in this function. After all, remember, this is a callback function. So when you go to the exact same observable and say, hey, can I subscribe, please? It says, sure, welcome on board, and starts a new session for you right here. And as a result, of course, the index started with 1 for your session. So there are 2 sessions being managed in this code, and that's why you see them in different times. So let's refresh and try it again. So you can see that I'm already down to 13 and 23, but I click on this, you can see the lag of the second one. This is a cold observable. It's a cold observable because it maintains multiple sessions for each one of its subscribers. There is no concept of anything being shared between these two. But there are times when you don't want that. There are times when you want multiple observables to really share the same session. Maybe you're in pursuit of the same data. For example, if you are observing the streets and maybe there's a car that's driving through the toll booth and you trigger a little event, maybe this person did not pay for it and trying to escape through, and you want to start monitoring this car, well, clearly you are interested in the same data at the same time. You don't want a different set of data at that point, so how do you deal with it? Well, before we talk about how to deal with it, I want to talk about one thing that's pretty darn cool, and that is you have an observable on this end, you got a subscriber here. But the beauty is you can have an intermediate subscriber who can be subscribing to an observable, but that subscriber can also become an observable to what's in downstream. This is called a subject. So what is a subject? Well, for example, let's say the gentleman on the second row, let's say, is an observable. So he is emitting data. And I might be interested in the data. I can subscribe to him directly. Or maybe I'm just having a little hard time hearing, and he here on the first row could become the subject right in the middle. He could be hearing what he is saying, and then he could amplify that and say it to me. Or it could be a translator, for example. The other person could be speaking a language that I'm not familiar with, but the person here could be translating and giving me the information. So what does the person in the middle become? He becomes a subject. A subject as in he is a subscriber to the original observable, but becomes an observable to me, the subscriber. But here comes the charm. How does this actually work? Well, remember one of the things we talked about. When you have an observable can send me a completed signal at times. But there is something else that's going on too. Me as a subscriber can unsubscribe from an observable. Well, guess what the subject is going to do now? If he is the subject, he is going to subscribe to the observable, but he's going to emit the data to me. At some point, if he decides not to emit data anymore, what is he going to do? He is going to send an unsubscribe to the observable that is upstream and send me a completed signal to tell me I won't get any more data and to tell the original source not to send any more data. So subjects have some additional responsibilities. Subjects not only can transform data that flows through them, subjects can also wire up this behavior of saying completed downstream and saying unsubscribed upstream as well, and they can manage this interaction very nicely. Well, so the point I'm making is I don't have to make any change to this particular code to get an hard observable out of it. So what I can do instead is I can go to the very end of it and I can create a subject. And the subject I'm going to create by calling share right here. So all I'm going to do is I'm going to just ask it to create an intermediary which will subscribe to the original observable up in the call stack, and then tell downstream that I'm going to really give you a shared session that you can deal with very nicely. So what does this really provide for us? Well, in this case, of course, all I've done is I called the share, and if I click on it, you can see the count right now well past 20, but I click on the subscribe another time, and you can see that they both are in sync with each other. I didn't have to modify the original code. All I did was I put an intermediary to say, I want this to be a shared session. So the original observable still is exactly what it was, but right now it has only one subscriber, which is the one that we called as share. The share itself, in turn, became an observable and entertains two subscribers, but those two subscribers are given a shared session that is managed by this intermediary. That's one very powerful concept in reactive programming, is that you have this chain of responsibility, and you can have intermediaries that are very powerful to carry on this behavior very nicely. So we saw the hot versus the cold observable and how we can use it, but I did allude to errors quite a bit. How is this going to work with errors, and how do we deal with errors typically? Well, to understand that, let's take yet another example here, and we will work with it. So let's get rid of this function for a minute. Let's get back here to yet another example, but this time I have a little text box in here. And you can see the text box is sitting there. Below that I have a subscribe, but I'm going to really start doing some work with this particular text box. But to take this to the next level, let's understand what we're going to do with the subscribe method. Well, notice I'm calling the subscribe function right here. So I'll put the subscribe function. And the subscribe function, it's going to need two things. It's going to need an input equals document.get element by ID. In this case, the element I'm interested in is the input element that is up here. But I'm also interested in the display element. So I'm going to say let display is equal to, and I'm going to say document.get element by ID, but this is going to be display. While we are here, let's say input.placeholder is equal to type something. So that way we know that we clicked on subscribe. So that's a good start. So let's go back to this little example, and I'm going to click on subscribe right here, and it says type something. So we are ready to try some little example. But let's take this to the next level. We talked about being reactive, and we talked about data stream. But what can be data stream? I gave a few examples. I mentioned that stock data could be a data stream. And so you register to tickers and symbols, and you got stock data that's changing, and you're monitoring a financial exchange. Great. Twitter could be a data stream. Twitter is an awesome example because you can sign up to Twitter, and you can waste the rest of the day monitoring what everybody else in the world is saying and not do any useful work. That could be a nice little stream you can subscribe to. Weather could be another data stream. But once we get a hang of stream, you then begin to ask, what else can be a data stream? Well, radio programs are data streams. Somebody talking could be a data stream. Time itself is a stream. After all, time is endless. It keeps on ticking. And so if you want a timer, why can't I use a timer as a data stream? Well, then you think about this. There is a beautiful language called Elm, and one of the things Elm is actually Haskell syntax for most part, and a little bit of F# syntax, but Elm compiles down to JavaScript, and Elm is touted as a reactive UI programming language. And one thing Elm does is, in Elm, all the things like mouse movement and keystrokes are all reactive streams. And you can imagine, if you want to monitor somebody's mouse movement, you could subscribe it as a stream. So whenever they move the mouse, then you get a notification as a subscriber. And depending on how fast they move the mouse, and depending on how much coffee they have had, they may move the mouse in a very different pace. So the point really is, you can start monitoring these events as streams, and that kind of bends the way you think about it, which is exactly what I'm going to do here, but in this case, using RxJS. So what can I do in RxJS for that? So I'm going to say get keyboard, let's say observable, and I'm going to call a function called get keyboard observable. Well, I'm going to start looking at a keyboard, and as I type stuff on the keyboard, I want to listen to them as an event, as a stream, rather than a traditional event. So for that, I'm going to go to say, let getKeyboard observable, and you know very well what this function is going to do. It's going to return an observable. So return rx.observable. But wait a minute, a few minutes ago, I called the create method. Why did I call a create method? Because I was the data source, so I called the create method. But now I'm no longer the data source. The data source is the operating system. It's going to start emitting keystrokes as I start typing. I want to be the middleman to take those keystrokes and emit it as an observable. So how do I do that? Well, that's the beauty of this. I can call a function called fromEvent really nicely. So I'm going to call fromEvent from the input. So I'm going to pass that input as the source over here, and that becomes the input. So I'll change it to source right here. And then, of course, what event are you interested in? Well, I'm interested in the key up event that I'm going to be generating from that. I'm going to receive that. Well, that's great. I'm going to have this observable given to me. But a key event is a key event. But what am I interested from this particular event? I'm interested in every single keystroke. So I'm going to call a map function right there. And then I'm going to say getKey as the function that I want to call right now. Well, that begs the question, what in the world is this getKey? Well, getKey is a function, and this function takes an event, and it simply returns event.key and returns the key from that particular event. So now we converted a keystroke into a stream, after all, an observable, and I'm going to start monitoring that. Well, what do I do when this happens? Well, you know very well what I should do now. I've got an observable with me, so the obvious function to call is the subscribe function. So I call the subscribe, and at this point I'm going to say, given a key, what do I want to do? Display.innerHTML, and in this case, innerHTML plus equal to, and I'm going to update the key into it. So we turn this into a little observable, and we subscribe to this observable, and we can start displaying that piece of data. Well, let's see if that works actually. So let's get back here and click on the subscribe function. And of course, it says type something, and I say ABC, and you can see that whatever I type here, it is displaying right there. So here's the subscribe, ABCD, and you can see that being displayed right there. So we turn that into a little event through the observable. But my goal was to show you about error handling. How do we handle the error? Well, to understand how we can handle the error, let's get back to this little example and play with it again. So I go back over here and I say, well, if first of all, I have a key on my hand. So let's say let key equals event dot, let's say, key. And then I'm going to return the key given to me. So no difference, just a little refactoring of the code right there. Just a little change to it. So ABC, again, you can see that it works. But I'm going to then say if in this case, key is equal to the letter F, or the key is equal to the letter F uppercase, then I'm going to say throw new error. In this case, I'm going to say, well, let us not go there, right? That's a little error message. The minute it sees the F, it says, don't do that. So in this case, of course, I'm going to go back and click on the subscribe, and I'm going to say A, B, C, D, F. Well, notice now it doesn't have anything more coming through, because the minute there is an error being emitted, the data channel shuts up. So that is why in this example, notice I subscribe A, B, C, D, E, F, and sorry, no more data for you. So that basically terminated the data channel. But of course, I have an error channel through which I can receive the error. So notice I got error. I'm going to say display.innerHTML equals error.message, and I can display the message that I get back from it. So I go ahead and click on subscribe, A, B, C, D, E, F. Well, let's not go there, and it doesn't matter what I click anymore or type anymore. It's not going to respond at this point, because error came through the error channel, the data channel shuts up, there's nothing coming through after that. So that is an example of how we can deal with errors as well very nicely. But I did mention that a beautiful transformation ensues from here. So a little circuit breaker concept you saw, but I want to talk about the filter and the map functions very nicely. This is one of the beautiful characters of here. I'm going to remove that error handling for a minute. Let's come back to this code. But the beauty is I can do a dot filter, and I can say, given a key, tell me that the key is not equal to the letter Z, and the key is not equal to the letter uppercase Z, so no sleeping allowed here. And so I filtered those out, as you can see right here. So if I were to do this, then I'm going to say dot map, given a key, I want to return key dot to uppercase, so I can convert it to a uppercase as well. So once again, let's go back and try this out. Click on subscribe, A, B, C, and you can see type Z or uppercase Z. You can see that nothing happens right there, and then I can type other characters after that. So that essentially is converting to uppercase, but it also filters out the Z, so we don't see that anymore. So you can see how we can do filtering. That's another beauty here is I didn't affect the source. I am the intermediary, and in this case I said, I want to start filtering the data along the way, and I'm also going to start really doing processing along the way where I can transform the data and we can do some really wonderful things with it. That again comes into a very powerful scenario. Well, the last thing I want to talk about here is one other concern, which is back pressure. Well, the reality is that you are going to have emitter that's emitting the data, the observable. You have observers that are processing it. But the reality, though, is there are times when you are maybe not as fast in processing as the data is being emitted. Well, what do you do in that case? Well, you cannot obviously be forced to work any faster than you can. Well, that's where the concept of back pressure comes in. So back pressure, the key thing to keep in mind about back pressure is there's no one right way to do it. So you need to handle it based on the realities of your project and application. There are back pressure on back pressure drop, which will just drop the data if you're too busy. Or back pressure buffer, it'll keep buffering the data when you're busy, and then when you have less load to process, you can process and empty the buffer. Well, on buffer, of course, only makes sense when you have times of peak load and slow load, and you can vary your processing. There are other solutions like, for example, debounce and throttle, which will allow you to decide how many requests and responses you want to process. And debounce says, I don't want to send any more than a certain request in a given amount of time. And if there's a response that's happening right now, and I'll let the time pass before I send the next request. Throttle, on the other hand, says within a given time, you can only do this much amount of work. And if you've done more than that, then wait until the time elapses to do the next piece of work. You can decide based on what you're trying to do, what you are interested in handling. So to give you an example of that, if I go back here, let's say back in this example, let's go ahead and refresh this. And in this case, let's say I'm going to subscribe, but let's say I start typing really quickly. Well, if you have noticed me type so far, I'm really, really good at typing badly. So I'll type and hit the backspace and type and hit the backspace. And you're like, gosh, all these backspaces and typing and hitting backspace, that's a waste. Can we just not wait until this guy gets stable at typing? Well, that's exactly where I can use debounce or throttle. So in this case, I can say debounce time, for example, 500. And notice I just threw it as an intermediary. Now what does this do? Well, and then I'm going to do one more change here. I'm going to remove this filter for a minute. I'm going to go back to this code and return, in this case, rather than returning a key for this event, what I would like to return is the event.target.value entirely. So I'm going to return the word itself. And then, of course, I'm going to turn it into uppercase and then display it. Well, in this case, of course, because I put a debounce here, so notice if I go back here and say ABC as a word, you can see that in this case, I am typing ABC, and it, of course, displays ABC as a word that comes in through really nicely. So write again, ABC. Well, but notice it waited for me. So I make some mistakes. I remove those mistakes. I type again, remove this, and then enter D. And all that mistakes I made were not visible because I said, just don't be frantic. let things settle down a little bit before you send it, so you can control the back pressure. And to the point I made, this is just one example. There are several other ways to control back pressure. Depending on your need for your applications, you can decide and pick whichever solution that might be applicable depending on what you're trying to do. Like, for example, buffering may be a solution under certain context, and that's what you want to do if that makes sense to what you're trying to do. So what did we learn so far? Well, what we learned here is that it's a rebirth of the traditional observer pattern, but there are differences as well in terms of having a data channel, error channel, and of course the completed channel. And you have this beautiful chain of responsibility pattern. You got intermediaries or subjects that can themselves be the recipients of the data from another observable, but turn around and become observable to downstream. And so you have a nice way to chain things, so you can have an observable design in one way, and you can control the behavior downstream based on what you're trying to do. Like I mentioned, this is something we are going to see quite a bit moving forward. Almost this is something we cannot escape. In a way, if you really ask me, I feel like there is a rebirth of the paradigm. So I kind of remember way back in time, I was watching the emergence of object-oriented programming. People were pretty much programming in structured programs and procedural style, and they were trying to wrap their heads around object-oriented programming. And of course, you can see that there were people making mistakes. We were talking about it, arguing about it, and then there was a quietness that ensued after that. And then eventually, we started building CRUD applications with it. I feel there is this another time opportunity now for yet another paradigm shift. I'm not going to say that we're not going to do CRUD applications anymore. We'll continue to do CRUD applications, but I'm going to challenge if everything we do becomes a CRUD, and I doubt it actually is. And I think reactive programming is the next paradigm shift that we are seeing, and I think we are going to start building applications very differently in the next about 5 to 10 years, and we are just wrapping our head around these kinds of ideas and concepts. If you ask me, this is definitely a great time to be in this area. So I hope you'll be very proactive in looking at this concept of reactive programming. Hope that was useful. Thank you.